So here are my examples of chapter 9.2, and I did switch the videos around up here. I started you out with the examples in the hope that the examples would be sufficient enough to get you refreshed on trig functions and how they're approached and how we solve them. So if you need to, please do go over it's only like 13 minutes down below, go over the lesson on the unit circle and trig functions. So we're starting with 9.2 because I consolidated 9.1 and 9.2. We're going to do that for a few of the sections in this unit. But in 9.2, problem number 5, what it says is find the point, the xy point, on the unit circle that corresponds with this angle. And so we're going to be looking at that unit circle. And here we have it. So, I mean, it's as simple as, first of all, we need to understand that all of these degrees and radians can be converted to each other. I do go over that in the video down below. So you have to understand that. And then the other thing is there's reason behind these numbers, why we have these x and y values for each one of these points on the coordinate grid. So keep in mind the unit circle is just a circle with radius 1 on the coordinate grid. So you can see, I mean, this is the point 0, 1. It's literally 0, 1, on the coordinate grid. You'll notice all of these other points won't even make it all the way to 1. So I mean, it's little itty bitty triangles in this unit circle with xy values. So I'm interested in this 45, 45. Whoa, sorry. I don't know what happened. We're interested in this 45, 45, 90 triangle, and I did discuss we have these special triangles that fit in this unit circle, and since they all have hypotenuse ones, they have special lengths to them. So you'll be able to see that all of these triangles, you can flip them and do whatever you want. I'm gonna flip. Well, that way. I mean, you can flip these and fit them to get some sort of horizontal and vertical movement to each one of these points on the unit circle. This horizontal movement that I'm interested in is over the square root of 2 over 2 and then up the square root of 2 over 2. So those are the xy values I'm interested in for that pi over 4. So simply put, the answer for this problem would be the square root of 2 over 2, comma, the square root of 2 over 2. Okay, so we're also going to do number 23 here, and what 23 asks you to do is evaluate the 6 trig functions of the given angle. So what trig is, it's a study of right triangles, and basically it's the study of horizontal and vertical movements and ratios of these sides of right triangles. So if I'm going to be on the unit circle, okay, I could bring you up there, but we can always sketch the unit circle. So here's my unit circle, radius 1. Alright, so the idea is this. There are 2 pi radians in an entire circle because there's 2 pi radiuses that fit around this circle. So 2 pi radians. Half of that would just be pi. And then so what I'm going to do is split that in half, and I'm going to be landing at pi over 2 on the unit circle. So this one's kind of a goofy one because we don't exactly have a right triangle going on. So keep in mind that we're always going to be observing, if you're just evaluating standard angles, you're going to be sitting at that origin and then evaluating from that origin. So you're going to be asking yourself, what is the sine of pi over 2? Now, sine is opposite over adjacent, and that's easier said than done, I guess, in this case, because if you had a triangle of this angle that we've created, you would look opposite of it and then put it over the hypotenuse, which is that angle opposite of the 90. Okay, so that's what you would be doing for that. However, this isn't a triangle, so we have to also keep in mind that sine, as well as so, ka, toa, as well as sine being opposite over hypotenuse, it's also just the vertical movement. So the vertical movement to get to this point, or in other words, the y value to get to that point, would be just 1. Okay, and we also have the reciprocal functions, which the brother of sine is going to be cosecant. So, I mean, since we had this right here was 1 over 1, basically, then the cosecant would just be the reciprocal of that. It'd be whatever this is, 1 over 1, which is, again, just 1. Okay, let's look at cosine. Cosine of this angle is one of our other 6 basic trig functions. Cosine is going to be associated with ka, so ka, toa, so adjacent over hypotenuse. Adjacent would be easily identified in a triangle as the leg that's touching that angle that you're interested in. However, since we're not really using a triangle right now, what you also have to associate cosine with is the horizontal movement. So the horizontal movement of this is really 0, and that's all there is to it. So 0, and then we have the reciprocal function of cosine, which is secant. So it's kind of goofy because sine s goes with c, c goes with s for these reciprocal functions. So what we would do is secant is the reciprocal of cosine, so what you can just do is do 1 over whatever that cosine was, so it's 0. So this right here, I hope you recognize, is undefined. And then finally we have tangent of pi over 2, which is sine over cosine, or think about it like this, TOA opposite over adjacent. So opposite was the sine movement, adjacent was the cosine. So now tangent is going to be opposite over adjacent. So 1 over 0. This right here is undefined. Okay, and then the reciprocal of tangent would be cotangent. And that's just the reciprocal of this, so you could look at it like this. Oops, I'm going to... it's 1 over 0. So we would have 1 times 0 over 1. So in other words, that's just 0. Cotangent is 0. So that was number 23. I'm also going to do another one with you that's not on your homework assignment, but just for the sake of review. I'm going to do 28, which is t equals -3 pi halves. So I just wanted to bring up what this negative means. If you're going to be looking on the unit circle, keep in mind if it's ever negative, instead of going in the positive direction, opening in the positive direction, which is counterclockwise, you're going to be opening in the negative direction. Here's my pi. If I went up, that angle would be pi. If I went down, that angle that I opened up from this angle right here would be negative pi. Okay, but you'll see that, I mean, they actually end up on the same spot. So if I want -3 pi halves, think of it like this. I would take my unit circle, cut it in half. Okay, that's going to get me pi. But then I want to take this pi and I want to also half that. So I'm going to half it right here. So what you can see is I've taken this pi, or this pi, which is 1/2 of that circle, that full circle, and what I've done is I've cut that pi in half here. So this is -1/2 pi, this is negative pi, and right here is -3/2 pi, which you'll see is kind of corresponding to just 1/2 pi. But this is now the angle that I'm trying to find, so 28 would just be just like what I did up above. I'm going to do one more. Sorry, I just want to do one more. That's once again not on your homework assignment. I'm gonna go ahead and do 5 pi sixths. So if I wanted to find, let t, or that angle, be 5 pi sixths, I'm going to go ahead and do another unit circle here to see where I'm at. Otherwise you can use your unit circles. But once again, you should be able to create this each time. So you can see the main thing here is that I've taken this pi and divided by 6. Here's my pi, and I'm going to half that pi. That would have been pi over 2. And then I'm going to split these 2/4 into 3 equal sections. Okay, so that's going to get me 1 pi 6, 2 pi 6, 3 pi 6, which is pi over 2, 4 pi 6, 5 pi 6, 6 pi 6, which is just pi. So that's what I'm looking at. This is my angle that I'm looking at right there. Okay, so I'm going to go back up to my unit circle here. Okay, so 5 pi 6, as I kind of did down below, is right there. And I'm going to go ahead and take one of my special triangles. And I am going to have to flip it. Okay, so here is what I'm looking at, and that's one of our special right triangles that fit on all of these points. So the idea is when we're looking at the 30, 60, 90 triangle, This triangle right here is going to have the longer leg, which is the square root of 3 over 2, and then this shorter leg, which is 1/2, and the hypotenuse is, of course, 1 again. So I'm going to take this with me. Okay, so I'm going to bring this back down here to my number. This is 24, by the way. Not on your homework, but it's good review. So here's my little mini triangle, but I am going to blow it up and recognize that I would have had to go back the long leg of my right triangle and then up the short leg, which is going to be 1/2, and then -3 square root of 3 over 2. So now if I wanted sine of this angle, which is 5π/6, by the way, that's what this angle is right here, and I need to calculate now what is the opposite over opposite over hypotenuse, which once again is when you're standing at this origin, you're going to look at this reference angle here, which is that smaller angle created between whatever your side length was, your hypotenuse of that angle that you opened, and then your x-axis. So it's that cute angle that's formed. So I'm going to be looking at this angle right here and asking myself, for this triangle, what is the opposite, or in other words, the vertical motion, which is going to be 1/2 over 1. I'm just going to keep it like that. Cosecant, then, of 5π/6, you can look at it like this. You need to take the reciprocal of that, so it's going to be 1 over 1/2, which is the same thing as just taking that and multiplying it by that divisor's reciprocal, so it's going to be 2. So there's my cosecant. What you're going to have is 1 over, and then the square root of 3 negated over 2. And then once again, you're going to get -2 over square root of 3. Can't leave these radicals on the bottom, so what you have to do is rationalize it. So -2 square root of 3 over 3. And then finally tangent, and those cancel out. I'm going to get -1 over square root of 3. At this point, what I'm going to do is quickly do the cotangent of 5π/6. That's going to be equal to just the reverse of this, because you can just flip it. However, this tangent really isn't done because I need to rationalize it. So that's how you're going to be working these ones. And then finally, I just want to look quickly at 37. You're going to be using, for number 37, these rules right here. And I just want to kind of, we'll get into this more, but cosine is what we consider an even function. It's because if you plug in some sort of negated value, it would have been the same thing as if you plugged in the positive value. So let's look at, this would be pi halves right here. Let's look at bad example. Let's look at pi. This eventually we're going to be graphing these, or this is the parent graph of the cosine function. And if you had plugged in cosine of pi, it would have been the same thing as if you plugged in cosine of -pi. You're going to get the same answer, which is -1. All right, versus these guys, we call these odd functions, because if I were to plug in sine of pi over 2, let's say, so I plug in sine of pi over 2, what's going to happen is I'm going to get a +1 here. Okay, let's put the negation of that, sine of -pi over 2. So here's -pi over 2. When you calculate that, it's going to be -1. When you plug in some sort of negative version of a given angle, it's going to be the negated overall answer. So I am going to do number 37, and I'm going to kind of fly through this. If sine of t is equal to 1/3, then if you plugged in and inputted in the negative version of whatever your original input was, the output is going to be negated. Okay, whatever you had for your output for sine of t, it will be negated when you plug in negative. Cosecant of -t equals, so I mean, just looking at this, you can flip those around. Okay, and that's it.